Welcome, and thank you for tuning in. My name is Suzanne Haas, and I'm a trainer at Google Cloud. And today, you'll be walking through a demo for deploying a simple web server containerized application to Google Kubernetes Engine clusters. Now, if you have any questions throughout today's event, please feel free to enter them in the text box below the video. We have Google experts on standby to answer your questions live. In this demo, you deploy a simple web server containerized application to Google Kubernetes Engine clusters. You'll learn how to create the cluster and how to deploy the application to the cluster so that it can be accessed by users. So you'll first build the image using a Docker file, which is a Docker configuration file, and then you're going to build the same image using Cloud Build config files. In this Quickstart demo, we're going to deploy a simple web server, which is a containerized application, to a Google Kubernetes Engine cluster. And we're going to learn how to create a cluster and how to deploy our application to that cluster so it can be accessed by users. Now, this demo, of course, assumes a basic understanding of Kubernetes. In the first place, we needed to enable Google Kubernetes Engine API. So we visited the Google Kubernetes Engine page, as you can see here in Google Cloud Console, and we created our project, which in this case is our first project. You can see that in the upper left-hand corner. And of course, we had to wait for the API and related services to be enabled, which took a couple of minutes. We also had to make sure that billing was enabled for our Google Cloud project. And for this quick start demo, we needed some available quota. So we needed one CPU engine in our cluster region and one in-use IP address. Now we're going to do our demo using Cloud Shell. And Cloud Shell is a shell environment for managing resources on Google Cloud. Cloud Shell comes pre-installed with the gcloud command line tool and kubectl command line tool. The gcloud tool provides the primary command line interface for Google Cloud, and kubectl provides the primary command line interface for running commands against Kubernetes clusters. So we're going to open Cloud Shell by clicking on the Cloud Shell icon and clicking on Continue. It'll take a moment while Cloud Shell provisions. And as you can see here, the system says it's provisioning our Google Cloud Shell machine. Since we haven't used it in a while, it may take some time to unarchive the disk. Now we're going to use our gcloud tool to configure two default settings: our default project and our compute zone. Now our project has a unique project ID. And when we first create our project, we can use the automatically generated project ID, or if you want, you can create your own. Ours is My First Project. The compute zone is the location in the region where your clusters and their resources live. For our example, it's going to be US Central 1A. So we're going to configure these default settings to make it easier to run gcloud commands, because gcloud requires that you specify the project and compute zone in which you want to work. You can also specify these settings or override default settings with flags such as -- project or -- zone and -- cluster in our gcloud command. So we're first going to set our default project ID. And we'll do this with the gcloud config set project. And I'm going to go ahead and use the project ID My First Project. And you see the project ID that's been assigned is Peppy Webbing 288622. And notice that I'm now logged in as Suzanne Haas at Cloud Shell, and here's my project ID indicated in the context here. The next thing I'm going to do is set my default compute zone. And because I'm in the central region of the US, I'm going to set my compute zone to US Central 1A. And notice that the feedback I'm getting is that my property for my compute zone has been updated. The next thing I'm going to do is I'm going to create a cluster. Now notice up here that I have the ability to automatically create a cluster just by clicking Create Cluster. But we're going to go ahead and do this through the command line, and we're going to create a one-node cluster with the name of our cluster. Now keep in mind, a cluster consists of at least one cluster master machine and multiple worker machines called nodes, as we found out in our training. And the nodes are compute engine virtual machine instances that run Kubernetes processes necessary to make them part of the cluster. So we're going to deploy our application to the cluster, and the application is going to run on these nodes. So to create our one node cluster, we're going to use the command gcloud container clusters create, and we're going to put in the name my cluster for the cluster name, so we have a mnemonic name. Now of course you'd want to use a name that was much more mnemonic and meant something to you and described what the cluster was doing or what you were deploying on the cluster perhaps. And we're going to specify that the number of nodes is 1. And notice we get some feedback here. VPC native is not the current default mode during the cluster creation. It will become the default mode. And we see the new created cluster and node pool is going to have auto upgrade enabled by default. And we're starting with version 1.18. Now be aware, when clusters are created, they are always created with the latest version of code and with auto update and auto repair enabled by default, so that Google will do health checks on your cluster. And those health checks will ensure that all the nodes of your cluster are up and running in the state that you have requested. This is what is called declarative configuration, where you can simply tell the system what you want, and it automatically carries out that function for you. Now this next step is to get authentication credentials for our cluster as soon as the cluster is finished. Now notice here, it's going to take a minute or two. And while the cluster is created, notice that the cluster is going to be health checked. That's to make sure that the state matches the state we declared. In other words, that it's up and running with a certain number of nodes. And now, as you can see, we have our cluster and its status is up and running. So notice down here, we have my cluster. It's already been created. The location is in US Central 1A. And the master code version is 1.15.12 GKE.2. The master node has an IP address. The machine type that's been deployed is a standard machine type, although you can select different machine types depending on what you're running in your cluster. So this is an N1 standard 1 machine type. And the node version matches the master node, of course. We've asked for one node with a running status, and so that's what's been deployed, a cluster with one node that should be kept running. So that's what we declared, and that's what the system gave us. Now the next step is to get authentication credentials for our cluster. So after creating our cluster, we need to get our authentication credentials in order to interact with that cluster. So the next command we're going to issue here is a kube control command that is going to configure, it's actually a gcloud command that's actually going to configure kube control and put it in contact with our cluster. So here we see gcloud container clusters get credentials, and we're going to have to put in the name of our cluster, so my cluster, to identify the cluster for whom we want to get our authentication credentials. And give it just a moment to notice that the system fetches the cluster endpoint that we're going to be interacting with and the authentication data. And we have a kubeconfig entry that's been generated for the cluster, our cluster named my cluster. So we should be all set. We have kube control configured to use the cluster that we've contained and created. And now that we've created our cluster, we're going to deploy our containerized application to it. And we're going to deploy an example web application called Hello. It's the Hello app. Now, GKE uses Kubernetes objects to create and manage cluster resources, and Kubernetes provides the deployment object for deploying stateless applications like our web server here. We also have service objects that define rules and load balancing for accessing the application from the internet itself. So to run our Hello app in our cluster, we're going to enter a kube control command that is going to create the deployment for our Hello server. Now, this Hello server image has already been uploaded to the image repository. So here we see image equals gcr.io/Google samples/Hello app. And so that is the repository where the application has been stored. And we have that uploaded automatically because it's a sample app. Now, if you have other apps, you would have to, of course, upload them to the container registry so they would be available for deployment. So this Kubernetes command, kube control create deployment, creates our deployment named Hello server, and the deployment's pod is going to run the Hello app container image for us. So of course, in this command, -image, as you can see here, specifies a container image to deploy. In this case, the command pulls the example image, Hello server, from a container registry bucket, gcr.io/Google samples/Hello app, as I pointed out before. And then :1.0 indicates the specific image version to pull. If you don't specify a version, then it's going to automatically pull the latest image. And notice down here, having issued the command, it only took an instant, and we see that our deployment app Hello service has been created. So now that our app has been created, what we can do is we can expose it so that users can actually access that app. And we can do so using the kube control expose command. Now, in this kube control expose command, we're going to see that we passed the -- type load balancer flag, which is going to create a compute engine load balancer for our container, and the -- port flag. Initialize public port 80 to the internet, and of course the target port flag here that you can see on the bottom routes the traffic to port 8080 of the application. Now be aware, load balancers are billed per compute engine's load balancer pricing. Now the next thing we want to do is check everything. So we're going to inspect and view our application by first inspecting our running pods using the kube control get pods command. So here we go. And we see the status of our Hello server pod that is ready and it's up and running. It hasn't been restarted. It's all ready to go. So we see one Hello Server pod running on our cluster. And we can look at our Hello Server service using the kube control get service command, which we're going to do next. And from this command, we'll be able to get the external IP address for our application. So we see our Hello server that is up and running. It's a load balancer server. It has an internal cluster IP address for communication internally of 10.3.254.43 and an external IP address, which we're going to want to copy so that we can visit that site externally and log in. And we see the TCP ports that are being used, port 80, and then of course a client port for our Hello server. So we've gotten the service's external IP address, and to view the app from our web browser, what we're going to do is we're going to open up a new tab here at the top. So let's go up to the top, and we're going to go to http:// put in our external IP address, and we're going to visit our Hello World application, which is running on our Hello World server in our Google Kubernetes cluster. And it's as simple as that. We've just deployed a containerized web application to Google Kubernetes Engine. So this concludes the demo. And in this demo, you learned how to deploy a simple web server containerized application to a Google Kubernetes Engine cluster. And you learned how to create the cluster and how to deploy your application to the cluster so it could be accessed by users. So thank you for watching, and please stay tuned for the next session. If you enjoyed this session and you know someone who'd benefit from watching, please share it with them. And feel free to continue the conversation and tag us with #Google Cloud OnBoard on social media.